Hi everyone, I'm Kev from UK Versity, and today I'm just going to be going through this NCFE Level 2 Functional Skills in Maths practice paper for you. Um, just a quick note before we start, the first section of this exam is non-calculator, so you cannot use your calculator in this first bit. There's only like 5 or 6 questions, so it shouldn't be too bad. The second section is calculator, so you're allowed to use one and it is much longer and is worth more. So, without further ado, let's just get started. Nico wants to save energy. She decides to insulate her home. Nico finds information about the numbers of homes in England with different types of insulation. Here's the table, and here's all the data. How many more homes? How many more homes have double glazing than solid wall insulation? So this is the number of homes with double glazing, 20.6 million, and this is the number of homes with solid wall insulation, 708,000. So we're asked how many more homes have double glazing than solid wall insulation. This is just a very simple question about taking away numbers from each other. And like I mentioned earlier, this is non-calculator. So you're going to have to do this in your head or with pen and paper or just by typing it out onto this box here. Um, Very simple question. Don't think I really have to go through this much, but the answer comes out to about 19,892,000. And that should be the answer for this question. All right, let's move on really quickly. 1B. Nico reads about the carbon dioxide CO2 emissions that can be saved with home improvements. And these are the different home improvements you can do, and this is how much you're saving per year. She decides to install loft insulation and solar panels. So when we see this and, we instantly should be thinking, okay, we're going to need to add these up at some point. Okay. Nico knows she produces 8,400 kilograms of CO2 emissions per year in her home. And what percentage of her CO2 emissions will she save? So we know that she's installing both of these. So let's just quickly do 476 plus 280. And this comes out to 756. So she's saving 756 kilograms of CO2 per year by installing both loft insulation and solar panels. Now, initially we know that she produces 8,400 kilograms per year in her home. So to find the percentage of CO2 emissions she's saving, we simply have to do 756 divided by 8,400 because we're finding the percentage. So 756 divided by 8,400. And you might think that this is a really annoying division that you have to do, a long division, you spend a lot of time doing this. But remember, you're doing an exam and you don't have a lot of time. Another method you could do here is just by simplifying this fraction down, finding the common factors of the top number and the bottom number, the numerator and the denominator. And you want to just simplify down this fraction. Really basic to start off with. Let's use 2 as a common factor. So 756 divided by 2 is 378, sorry. Over 4,200. And you know what? We can do the same thing again. Just use 2 as a common factor. And we'll get 189 over 2,100. Then it's a little bit less obvious what to do here, but 189 is actually divisible by 3, and so is 2,100. So it comes out to 63, I believe, over 700. And you should be able to see now 63, 700. They both have 7 as a factor. 63 is just 7 times 9. 700 is obviously 7 times 100. So we see that this just simplifies down to 9 over 100, and that is the same as saying 9%. All right. So now we're moving on to 1C. Nico wants to work out the total cost of the electricity she used in January. The total cost is made up of the cost of the number of kilowatt hours used plus a standing charge. Right. So initially we see this really big number here, but we're just finding out the total cost of electricity she used in January. So that's the difference between this number and this number because this is the reading on the 1st of January and this is the reading on the 1st of February. We're finding the difference, which means we're finding just how much she used within the month of January. Um, I don't really even need to read the rest of the question here because you do know that you're going to have to do this. But just for the sake of exam prep, we should be reading the whole question before we do anything. Nico thinks the total cost is less than £35. Is she correct? Show you how you decide. Right. So, uh, with this, we know that we're going to have to work out how much it is costing. So I'm going to do what I said just now, 16,000 minus 15,843 to find the difference and therefore the number of kilowatt hours she's used in January alone. Um, so this is just 220 kilowatt hours. You should be putting units wherever. It's helpful for you to understand and also helpful for the examiner because then they know that you're on the right track. Also, units are almost definitely needed in your answer. I would say always put them in your answer if you have units. So we know she's used 220 kilowatt hours in January, and we see here that the cost per kilowatt hour is 12.69 pence. So with that, we should be able to see that to find the total cost of find the total cost of January, that's just 220 kilowatt hours times 12.69p. And that gives us that should give us 2,791.8 pence. And you're gonna have to do this in your head. You have 15 minutes to do this whole. Sorry, you have half an hour to do this whole section. So about 5 minutes per question, right? You've got a lot of time. You'll be able to do this fine. But yeah, so now we have 2,791.8 pence. This is the same as 27.92 pounds. And the reason I say 92 is obviously because we don't have 0.8 pence in real life. And and obviously if you're paying for electricity, they're going to overcharge you rather than undercharge you. Right. Now, we can't forget this part of the question where she said where it said that there's a standing charge that we need to add. Here's a standing charge of £5.84. So 5 plus £5.84 is 33.76. Right. So Nico thinks that the total cost is less than £35. We've just calculated 33.76. Therefore, Nico is correct as she is paying £33.76. All right. Moving on. 1D. Nico gets her annual electricity statement. She reads that the average rate she paid over the lot of the year was 13.429 pence per kilowatt hour. Calculate this. So essentially, we're just going to be doing 13.429 minus 12.69. Obviously, everyone should know how to minus things away. So just going to blast through this really quick. The answer is 0.739. Right? Sorry, we should put the answer into the answer box, obviously. Next. Nico used 2,550 kilowatt hours of electricity last year. Solar panels would produce 850 kilowatt hours of electricity per year for Nico. What is 850 as a fraction of 2,550? Give your answer in its simplest form. Right, so this is very similar to the question that we did before. This is just about simplifying your fractions down. So we have 850 over 2550. Instantly, we see that they're both a common factor of 10, or have 10 as a common factor, I should say. Um, so we see that this simplifies down to 85 over 255. And instantly again, we should see that 5 again is a common factor. So this is the same as 17 over 51. And this is a bit more tricky, but 51, sorry, is actually divisible by 17. And you get 1 in 3 because, well, 17 times 3 is 51. There you go. And that is the most simplest form you can have 850 over 2,550 as 1 in 3. All right. Now moving on, this is the last non-calculator question. If Nico installs solar panels, she'll save £100 on the cost of electricity each year. So every year she's spending £100 less on electricity. She gets these quotes for the cost of installation 1,600, 2,100, etc., etc. How many years will it take for the savings to equal the median cost? So let me just highlight this real quick. The median cost of installation. You must show all of your working. Okay, so first of all, most important, the key word in this question is median, right? So we have to find the median, and what we know about the median is it is the middle, essentially, of your range of data. Here is our range of data. We can see that the smallest number is 1550, and the biggest number is 3400. Right. Okay, ignore me. I am just being stupid. This is the median. Well, we're trying to find the middle number. Yes. So we're going to be lining up all the numbers together from smallest to biggest because we are trying to find the median, right? The median is the middle number. So I'm just going to write this out so it's a bit easier to see. 1550, the next smallest should be 1600, then 2100, then 2600, 2800, and finally 3400. And this is in ascending order. Right. So the median cost is in the middle. But as we can see, there's 6 numbers. The middle is right here in between 2,100 and 2,600. So the way we work this out is by taking 2,100, adding it to 2,600, and dividing both of these by 2. And the point of this is we're trying to find the middle between these numbers. And realistically, you don't really have to do this at all. If you want, you can just figure out the middle. You see that the difference is 500, which means half of 500 is 250, and you should see that the middle is 2,250. Let me just double check this answer. Sorry, 2,350. Right. So if the median cost is £2,350 to install, and the question is how many years will it take for savings to equal the median cost? We're saving £100 per year, right? As given in this part of the question. So if we're saving £100 per year and it costs 2,350 to install, 2,350 divided by £100 is 23.5 years before the before the cost of electricity is saved. Right, so that's the answer, 23.5 years. And we don't need to put years because it's already there. And this should be the end of the non-calculator section. Obviously, follow the instructions you see on screen during your actual exam. But I'm just going to click finish and go next. Section B, as we can see, calculator. We are allowed one, and you should definitely be using one. So let's just begin really quick. 2A, Ben manages a dairy farm in Edinburgh. The farm covers 147 hectares of land. Hectares. the ratio of the area of land occupied by buildings to the area occupied by pasture is 2 to 5. So here we can instantly see that this question is about ratios amongst other stuff as well. And matter of fact, if we see here, it's about ratios and conversions. So Ben wants to buy enough grass seed to cover the entire pasture land. A sack of grass seed covers 1 acre of land. How many sacks of grass seeds does he need to buy? Right. So we see here that a sack of grass seed covers 1 acre of land, and we know that a hectare is 2.47 acres. So we're trying to work out how much seed he has to buy to cover the entire area of pasture, which is also, given this ratio of the entire land. So first of all, we want to find out the area of the pasture first, right? Because we need to figure out how much grass to buy to fill up the pasture. So we're told that the farm has 147 hectares of land, sorry, and the area occupied by pasture is 5/7 of 5/7 of 147. The reason for this, right, is because we're given this 2 to 5 ratio, and if the ratio of buildings to pasture is 2 to 5, we add up 2 and 5 and we get 7. So what this means is 2/7 of the land are buildings. You don't need to write this in your exam. I'm writing this so you can see. 2/7 are buildings, right? And from that logic, we see that also 5/7 is pasture. So what we need to be working out is 5/7 of the 147 hectares of land given here. And obviously this section is calculator, so just punch this into your calculator and you will find 105 hectares. If you want to know, you can just simply do 147 times 5 divided by 7, or do 5 divided by 7 and then times 147. We'll get 105 hectares, and this is the area. This is the area of pasture on the farmland. Great. So the problem now is we're told how many acres of land 1 sack of grass seed can cover. But we are now still working in hectares. So let's convert our hectares into acres. 105, we see that 1 hectare is 2.47 acres. So simply just 105 times 2.47, which equals 259.35. Obviously, I'm not going to go through any calculations anymore because we are using calculators. You're just going to be punching numbers in. All right. So now we've got 259.35. However, this question is asking about like a real life thing, right? Because we're buying sacks of grass seeds. In real life, you can't go to a shop and just ask for 259.35 sacks. You have to buy whole sacks. So here the answer is actually 260 sacks of grass seed because you have to buy more than you need here, and we're just going to have a bit remaining, which doesn't really matter. All right, 260 sacks of grass, and that should be the answer for this question. Okay. 2B. Ben uses soy meal in the feed for cows. The soy meal is imported from the Cerrado region in Brazil. I am definitely butchering this. Edinburgh has a longitude of -3 degrees and a latitude of 55 degrees. Cerrado has a longitude of -14 degrees and a latitude of -47 degrees. So instantly here we can see that this is really tricky wording because it's worded like it would be on a map with the latitude, longitude, and degrees and stuff. But as soon as we look down, we see this graph that has been labeled with latitude and longitude on it. So we see that here these numbers, these degrees, are actually just coordinates for us to plot. And we see this because they're telling us to plot the positions of Edinburgh and this radar region onto this coordinate grid. This is very simple. Obviously, if it says Edinburgh has a longitude of -3, we just look at the longitude, and -3 is just there. And the way we can see this is obviously it starts at 0, we go down to -10, and each of these individual smaller boxes is worth 2 because there are 5 boxes within this 0 to 10 range. Therefore, -3 is just there. Okay? And a latitude of 55 degrees is up here, in between the 50 and 60. So let's just add this point on. We see that -3 and 55 should coincide right about there. Okay, not quite. Not quite, but it's about there if I can be precise. I suppose I don't have to be too precise on this practice test for you guys, but you get the idea. You understand how to do it and why we're putting it there. So just going to blast through this. -14 and -47. So -14 for the longitude, which is here, this second dot here. And a latitude of -47. So -14, -47, you go down here, and it should be right there. And obviously then you should label these. The first one we did was Edinburgh, so this is Edinburgh. Save. And this one is the Cerrado. All right. That should be the answer. I'm aware that this is a little bit off. It should be a little bit more to the left and slightly up just in the middle of the box, but it is what it is. I'm not trying to waste your time, so I'm just going to move on. This picture shows a haystack on the farm. Draw the side elevation of the haystack. This is pretty self-explanatory, just telling you to draw what this haystack would look like from the side. If you imagine standing right here, looking at the haystack, what you would see is just the circles. Oh, drag and drop the shapes. You'll just see 4 circles on the bottom, 3, then 2, then 1. Pretty self-explanatory, I think. Also pretty intuitive because this is just about essentially real life, what you would see, right? You can just imagine this. So just going to really quickly drag and drop these onto there. And that's, if you have a look here, is what it would look like if you saw it from the side. All right, moving on. The cows are milked in milking units. It takes 34 seconds to milk 1 cow in a milking unit, and Ben has 2 milking units. Right. Ben thinks if they had 3 units, it would take 45 minutes less to milk all 402 cows. Is Ben correct? Show how you decide. Okay, useful information to note. Ben has 2 milking units, and he has 402 cows in total. And each milking unit takes 34 seconds to milk a cow. All right. So, Ben thinks if they had 3 units, it would take 45 minutes less to milk all the 402 cows. We see here that we're trying to work out how long it would take with 2 units, and then how long it would take with 3 units, and then finding out the difference. So with 2 milking units and 402 cows, right? If we're milking 2 at a time, that means we only need to milk 201 times, if that makes sense, right? Because you're doing 2 at the same time. So 201 times of milking, and each time we milk, it takes 34 seconds. We can just do this. 201 times 34 is 6,834 seconds. which is the same as 113.9 minutes. And the reason we're converting to minutes is just because the question was in minutes and it will make it a bit easier to work everything out later. Um, so now with three units, you're doing three at the same time, which means this 402 cows, we're only milking 134 times, right? Because we're doing three at a time. So now it's 134 times, well, 34 seconds per cow to get milked. And this is 4,556 seconds, which is about 75.9 minutes. So now we just have to work out the difference because that's literally what the question was asking, right? It would take 45 minutes less. Ben thinks, is this correct? So 113.9 minus 75.9, punch this in a calculator and you'll get 38 minutes difference. Therefore, Ben is wrong as there is a 38 minute difference. Not, well, we don't really have to say that, but 38-minute difference is obviously not 45 minutes. So that should be right. And let's move on. 2E. The total amount of milk produced each week in the UK is 267 million litres. That's a lot. Ben's cows produce 80,100 litres of milk each week. Ben also thinks that his cows produce 0.02% of the total amount of milk produced in the UK each week. Is he correct? So, excuse me. So, this is simply just a question about percentages. So if Ben produces 80,100 liters per week and the UK produces a total of 267 million per week, just going to add these in so it's a bit nicer to look at. You can just punch this into your calculator, obviously, with this section being a calculator test. It'll come out to 0.003, which is the same as 0.03%. Because percent is 100 times your fraction or decimal number that you got. So we see here that he is incorrect because he thinks that he produces 0.02%, whereas we have just worked out 0.03%. He is incorrect. Okay. I'm just going to reword this a bit nicer. Sorry. He is incorrect as he produces of the 0.03% of the UK's milk. Okay. Now we move on to 3A. Flower shop. Zofia runs a flower shop. She applies for a business loan of £24,000. The rate of interest is 2.5%. Her first repayment, F, is 450. Her second repayment, S, is given by the formula this, where A is the amount of loan, R is the percentage rate of interest. Zofia thinks the difference between her first repayment and her second repayment will be less than £1. Is Zofia correct? And show how you decide. Now, initially, this question looks really scary because, there's a lot of stuff, there's definitions and multiple parts and all that. But all you really need to do is just put all these numbers into this equation, into this formula, and that's essentially all you need to do, right? You're given everything. A here, all of the letters, all of the unknowns in this equation is given to you as information. So A, amount of loan, we see here is 24,000. F, first repayment, we're also given here, £450. R, the rate of interest, we're also given here as 2.5%. So literally all you need to do is put in the numbers. So 24,000 as A, 24,000 goes into here. F, first repayment, 450, 450 goes into here. Also, this is A again, so you put 24 in. And R is 2.5%. So let me just write this all out for you to see. 24,000 over 60. This is this first term here, plus A minus F over 12. So A is 24,000. 24,000 minus F, which is 450, and divided by 12. And then now we are taking this and multiplying it by 2.5 over 100. And literally just work out A over 60, work out this over 12, work out this, and then add and multiply. Multiply first and then add them. And it will come out to be, it should come out to 449.06. Yep, that should be the answer. So 449.06. And we can see that her first repayment, oh, sorry, I should mention that 449.06 is the second repayment, which is here, given here. And the question is talking about the difference between her first repayment and her second repayment. We see the first one is 450, so 450 minus 449.06, and that comes out to 0.94 or 94 pence. So we see that we got the answer of 94p, and that is less than £1 difference. So Zofia is actually correct. Correct, as the difference is only 94 pence. Moving on. All right. Zofia wants to put new flooring down on the shop's display space. The space is shown in the diagram. This is the space, 4.35 meters by 4.35 meters. And we can see that it is in a quarter circle. The flooring can be cut to fit any size, right? So we don't have to be worried about stuff like that or like leftover pieces. Zofia must buy whole meter squared of the flooring. See, now this is an important sentence. You must buy a whole meter squared of the flooring. She finds these prices per meter squared. Here are all the different prices. And Zofia chooses the flooring which has the modal price. How much does it cost for flooring? For the flooring Zofia needs, you must show you're working. Right. First things first is Zofia chooses the flooring which has the modal price. And the modal price is telling you to take an average, and specifically by using the mode. And what the mode is the mode is the most common number that appears, essentially. It's the one that exists more than the others. So what I mean by that is, if we just take a look at these numbers here, we see that 24 only comes up once. 21 only comes up once. Same can be said for 28 and 19. However, 26 we see comes up twice. And this means that 26 is our mode, or the modal price. So we're going to be using £26 here. And this is, useful for later. £26 is the modal price. So we need to figure out how many meters squared we need to buy to fill this space, right? It's a bit weird that it doesn't tell us outright this is definitely a quarter circle. However, it's the only thing it can be, because it gives us pi, and this is the same, so the radius is the same either way, and we have a right angle here. No, telling us that it's a quarter for sure. Um, so knowing that this is a quarter circle, we need to find the area of this space. And obviously, we've sent out formula sheets and stuff. You should know these. The area of a circle is given by pi r squared. So pi times r, pi times r times r, essentially, because r squared is just r times r, where r is the radius of your circle. So here we're already given a value of pi, so we can just use that. 3.14 times the radius, which is 4.35, times 4.35, and that will give us that will give us, sorry, give me just 1 second, 59.4 centimeters squared, or sorry, meters squared, I should say. Not that this matters that much, but it's helpful to note it down, like I say, because it keeps everything nice and tidy, and you're not converting between different units when you don't need to, or not converting between units when you do need to. So here we're given 59.4 meters squared as the area of the circle. However, we know that this is not a full circle. Obviously, this is a quarter circle, so we're gonna have to take a quarter of 59.54. Oh, sorry, 59.4 just, and that comes out to 14.85 meters squared. Now, remember what I said earlier about this being important. Zofia must buy a whole meter squared of the flooring. So we can't just buy 14.85. Sorry, it's supposed to be 5. We can't just buy 14.85. In fact, we need to buy 15 meters squared, because obviously we can't buy 14 because then we can't fill all of the space. And so yeah, we buy 15 meters squared, and we're told to use the modal price. We've already worked this out. The modal price is £26. And so this is simply just 15 times £26 to get 15 times £26 to get £390. And that will be our answer here. And it should be right. So let's just move on. Now coming up to 3C. This is a very simple question. Obviously, Zofia needs to store fresh flowers at 3 degrees Celsius, and the temperature in the fridge is -2 degrees Celsius. The question just simply says, work out what 3 minus -2 is. So we're just going to be doing some arithmetic on negative numbers here. 3 minus -2. I'm sure you guys already know this. I don't think I need to go too much into detail about this, but essentially, if you're minusing a negative number, that's like the same as adding. If you think about the number line and how that works, where you're shifting it around, this should come quite naturally to you. And so we see that 3 minus -2, given that the double negative cancels, it's basically like saying 3 plus 2. So the answer is literally just 5. Oh, not 4. Funnily enough, just 5. Oh, that's not supposed to happen. Just 5. Right. And that's that. Moving on to 3D now. Obviously, I'm trying to go through this really quickly because I don't want to waste any of your time. Zofia designs a symmetrical logo for her flower shop, and this is the logo. The angle labeled A is 116 degrees. What is the size of the angle labeled B? Okay, so first of all, we can see that this shape is four-sided. So we see it as 4 sides, and this is what we call a quadrilateral. Quadra for 4, and lateral, well, shape. And really, what this is a rhombus. but that doesn't really matter that much. We're told that the angle A is labeled 116 degrees, right? And as we can see from this shape, it's a symmetrical logo, which means this corner here, this angle here is also A, aka 116. And that goes for this corner or angle as well. And this is the same as B. Right. So now we see that if angle A is 116, and we know that this is also angle A, let's just add them up right now to get 232. Sorry, 116 equals 232. And so we know that angles within a quadrilateral, within a four-sided shape and a circle, add up to 360 degrees. So this is what we call the internal angles because they are on the inside of the shape. And like I just mentioned, the internal angles of a quadrilateral add up to 360 degrees. Right. And we know that these two angles here are already 232, right? So if we take that away, we're left with a remainder of 128 degrees. Right. So now we have 128 degrees missing from this, and we know that there's only two angles left, and they're both B. So if 128 equals 2B, or 2 times B, then we know that B must equal 128 over 2, which is 64 degrees, and that will be your answer. B should be 64 degrees. And, you know, as good exam practice, what we should be doing is checking through our questions and stuff, especially when we have a calculator. It gets really easy. So let's just have a double check. 64 times 2, 128. So there we go. And, you know, 116 times 2 is 232. Add them together, and we get 360. So that's fine. We've double checked and it's correct. Moving on. 3E. So Jasper orders 2 bunches of flowers from Sophia. The first bunch has white, pink, and red flowers in the ratio of 4 to 3 to 1. So for every 4 white flowers, there are 3 pinks and 1 red flower. In the second bunch, 40% of the flowers are white, and the rest are pink. Oh, sorry, I shouldn't have highlighted this. And the rest are pink, which means 60% are pink, or 6 out of every 10 are pink, and 4 out of every 10 are white. Jasper picks 1 flower at random from each bunch. What is the probability Jasper picks out a pink flower from each bundle? So what we're calculating here is the chances that Jasper reaches his hand into both bags and gets a pink flower from both of them. So to work that out, we need to figure out what the chances of getting a pink flower from just the one bag first. So let's just have a look at this first line here. We're told that the ratios are 4 to 3 to 1 in terms of white to pink to red. So what we want to look at is the chances of getting pink within this first bag, right? Or within this first bunch. And so if the ratio is 4 to 3 to 1, the total here is 8. And it's very similar to the question before that we've also already done about ratios. We know that in the first bag, 3/8 of the flowers are pink. And with this same logic, we look at the second line here. We see that 40% of the flowers are white, which means 60% are pink. So 6 out of 10 are pink, which is the same as saying 3/5 in the second bunch. Right, just simple organizing right now. All right. So if the chances of getting a pink flower from the first bunch is 3/8, and the chance of getting a pink flower from the second bunch is 3/5, then then the chances of getting a pink flower from both at the same time is just 3/8 times 3/5. And we can just work this out with a calculator. This comes out to 9/40, which is the same as saying 0.225 or 22.5% is also works. They're the same thing, they're equivalent. So I'm just going to use 22.5% because it just makes it a bit easier to look at, I guess. So yeah, this is the answer. Obviously, to work out 3/8, we're looking at the ratios, right? If there's 4/8 of white, 3/8 of pink, and 1/8 of red. And we know this is right because if you add up 4/8 and 3/8 and 1/8, you get 8/8, which is 100%. So that's how we know it's correct. All right, moving on to 3F now. The total cost of Jasper's flowers is £66. Zofia gives Jasper a 12% discount off the total cost. Select the amount Jasper will pay. This is very simple, very intuitive. Obviously, if you ever go to the supermarket and you buy something that's on discount or, reduced to clear, that kind of stuff, if it has a percentage on it, you've probably worked this kind of stuff out before. So, a 12% discount off the total cost of £66 is what that means is you're doing 66, you're finding 12% of 66, right? So you do that by just doing 66 times 0.12 because 12% is the same as saying 0.12. And that will give you 7.92. Yeah, that should give you 7.92. And that's not the answer because that's how much we're taking off, right? That's the discount. 12% of 66 pounds is 7.92. That's how much we're taking off the total price. So the answer is not 7.92 here, but we're doing 66 minus 7.92, which is 58.08. So C is the correct answer. Okay, moving on to question 4 now. So Mikey is planning a narrowboat holiday. The scatter diagram gives information about the length and hire cost of 18 narrowboats available. Click the icon below to view the scatter diagram. So this is how we're going to be accessing it. The question is, what fraction of the narrowboats are over 60 feet long and have a hire cost of less than £1,700? So one thing to note is here it says over 60 feet long. So over 60, that means it does not include 60. It means it needs to be more than. And here it says less than 1,700. So once again, it does not include 1,700, but everything below that. So let me just open this up for us real quick. And we see that here we have the length in feet at the bottom on the x-axis and pounds cost on the y-axis. So what we're going to do here is find 60 feet because we know that we're trying to find the fraction of narrowboats over 60 feet long. So we see here that this is 60 on the length in feet axis, and we're going to just essentially draw a line with our mind, right? We're going to draw a line here and say everything that is above this line or over 60 is, what we care about. And the same can be said for the cost being less than £1,700, right? As you can see here, 1,500, 2,000. Each of these little boxes is 100 because we can count here. 0, 100, 200, 300, 400, 500, and that's correct. So 1,700 or 1,700 is right here. So we're just going to follow this line across, right? This is the horizontal line for £1,700, and we're looking for everything less than 1,700. So now it should be quite obvious to see that we're looking for everything within this rectangle here. under 1700 and above 60 feet. And here we can count one, two, three crosses within the area we're looking for. So I'm just going to note this down really quick for our knowledge. And because we're trying to find the fraction of narrowboats that are over 60 feet and have a hiring cost of less than 1700, we need to know the total number of narrowboats as well. Actually, we know this, it's given 18, but if you also count up all the crosses, it will be 18 as well. And so we know that the question is asking about the fraction, so we're taking 3 over 18 as to find the fraction, and this is the same as saying 1/6. So 1/6 of all the narrowboats, oh, sorry, let me open this again. 1/6 of all the 18 narrowboats are longer than 60 feet and cheaper than £1,700 to rent or hire. All right. So now let's move on to 4B. Mikey is going on a holiday with 4 of his friends. They need to hire a boat and a minibus. The friends will share the total hire costs equally, and Mikey has this information about the cost of hiring a suitable narrowboat. We're given here, this is what we call grouped data, as normally you see tables where it's just 1,500 or whatever, 2,000, but here we have a range. We can see here that there are 3 companies whose costs are between 1,000 and 1,500, and this is why it's grouped. Okay, so some useful information already is this. The friends are sharing the total hire cost equally, and also we need to hire a boat and a minibus, and also that there are 4 friends. The cost of hiring the minibus, including fuel, will be £360. This is important here. And use an estimate of the mean cost of hiring a narrowboat to work out Mikey's share of the total hire cost. So this is essentially the answer. This is what we're trying to find out. Okay, so first of all, we need to find the mean cost. And when finding the mean of grouped data, it can be a little bit different. And just before we do that, everyone knows what a mean is, right? So a mean is one of the forms of taking an average where you add up all your values and you divide it by the number of values you've had to find essentially the average, the mean. But with grouped data, it's a little bit different. Obviously, we can't just do 1,000 plus 1,500 plus whatever, because we don't know exactly what this data is. It's just in between here. So what we're going to do is we're going to just take an estimate or an average of these data here. We're actually going to take the mean of this data here. So by taking the mean of this, or, well, it's the same as taking the median, I suppose. It's just halfway in between, which means for the first one here, we're going to be working out with 1250. And the second line here, we're going to be working with 1750. And this third line, we're going to be working with 2250. Now, can everyone see why I've done this? Whereas the 1250 is in the middle, the midpoint of 1,000 and 1,500. 1750 is in the middle of these two, and same for this and this. The point is we're trying to find an average between these, and then using these averages, we're going to find the mean. And how we find the mean with grouped data, and well, with just tables in general, is we have all the data on the left, this column here, and we have the frequency of how often they appear. So as we know from taking a mean, you average all the data, you add up all the numbers, and then you divide it by how many you've had. So here, to add up all the numbers, we've obviously got 3 companies who are costing about 1,000 to 1,500. So on average, these 3 companies will be charging $37.50 in total for all 3 of them, right? So we're just going to repeat this for 5 and 2 as well. And Here we get 8750, and here we get 4500. Right. And then what we need to do now is add up all of these values here to get our grand total, right? The one we're using to find the mean. And 3750 plus 8750 plus, 8750 plus 4500 is 17,000. We're lucky that it's just a nice round number. And so what we need to do now is find the frequency, find the total number of companies here, because like I mentioned earlier, to find the mean, we're adding up all the values and then dividing it by the number of values we've got. And here we're given 10 companies. So over 10 companies, the average or the mean is £1,700. So the mean cost of hiring a narrowboat is going to be £1,700. So here we've worked out this bit already. And you'd think that the question is done, but remember we have this extra bit of information about hiring a minibus, as we know they need to do a boat and a minibus. So we're going to be adding the cost of the boat, or the mean cost of the boats, which is 1,700, to 360, which is the cost of hiring the minibus with the fuel. And this comes out to £2,060. Now, this is still not the answer yet, as we are working just Mikey's share of the hire cost. And we know that Mikey has 4 friends, all the friends are sharing it equally. So pretty simply, we're just going to do 2060 divided by 5, as there are 5 people going on the trip. And if we're spreading it evenly, it's like when you go to a restaurant and you split the check 5 ways, doing it the same thing. £412 is the answer for Mikey's share. All right. Now we're going to be moving on to 4C. We only have 3 questions left, so we're almost done. This immediately looks like a pretty simple question on ratios, but let's just have a read. Mikey uses a map of the waterways to plan a journey to Worcester. The scale on the map is 1 to 500,000. And the distance to Worcester on the map is 4 centimeters. Mikey thinks that the actual distance to Worcester is 2 kilometers. Is Mikey correct? So, yeah, I was right. This is just a simple question on ratios. And we know that the scale of the map is 1 to 500,000. So if the distance to Worcester on the map is 4 centimeters, in real life, that would be 500,000 times larger. So if we just do 4 times 500,000 in your calculator, you don't need to, if you can just do that, you'll get 2 million centimeters. Okay, now 2 million centimeters is the same as 2,000 meters, because, sorry, 20,000 meters, almost messed that up. 20,000 meters because 100 centimeters go into a meter. And we should know as well that 20,000 meters is the same as 20 kilometers, and thus Mikey is incorrect, as the actual distance is 20 kilometers, whereas he thought it was 2. Matter of fact, I almost made the same mistake that Mikey did. So that just shows the importance of checking your answers after you do them in your actual exam. And make sure that you don't just leave things be. Always double check. D. The friends travel on the narrowboat to a restaurant that is 8.4 kilometers from the starting point. There are 2 locks to pass through on the way to the restaurant. When not in a lock, the boat travels at 3 miles per hour. So just going to highlight this real quick. It takes 15 minutes to pass through each lock. How long will the journey take? Give your answer in hours and minutes. So this is very important, as we know we have to convert our answer into hours and minutes afterwards. We don't want to leave it in seconds or whatever. All right, we're also told that this is 8.4 kilometers. Okay, so when not in a lock, the boat travels at 3 miles per hour. And we're given a conversion here, so we know that we're going to have to use it. This question is going to be about converting between miles per hour and kilometers per hour, and also the simple equation of speed equals distance over time, which you should know already and know roughly how to manipulate it. And so if we have if our boat is traveling at 3 miles per hour, and the entire journey is 8.4 kilometers. What we're working out is how long it'll take, right? So the simple equation that we're given that we should know is speed equals distance over time. And the problem here is we're given our speed in miles per hour and the distance in kilometers. And this is why I've been hammering that you need to check your units, make sure your units are right because you need to be converting between units when needed. And this is a perfect example of that. So we're gonna be converting the kilometer distance into miles. You can do the other way around if you'd like. It doesn't really make a difference. It doesn't really matter. So 8.4 kilometers times 5/8, and just before I move on, I'm just going to explain how I got this. The conversion is 5 miles is the same as 8 kilometers. So this is the same as this is like saying 1 kilometer is 5/8 of a mile. Because if you've done any algebra or rearranging, you can see that if we divide both sides by 8, 5 over 8 miles is 1 kilometer. So that's where I got 5 over 8 from. And we're going to do 8.4 times 5 over 8. And this is 21 over 4, which is the same as 5.25 miles. Lovely. So now we have 5.25 miles, we have the distance in miles, and we're given a speed as 3 miles per hour. By using this equation, we can see that we can plug in our numbers to get 3 miles per hour equals 5.25 miles distance divided by time. And here we're working out the time. So what we want is to get the time variable on the left side or on its own side of the equation. So what we're going to do here is just rearrange this around a little bit. If we multiply both sides by the variable time, we get 3 times time equals 5.25 miles. I'm just going to not use the units here because they're in the same units. Actually, no, I will just use the units. Yes. Miles. And then we can divide both sides by 3 miles per hour. And we'll get time is 5.25 miles over 3 miles per hour. Okay. And you don't really need to know this, but this is for your own information. As to why this works and how we can get this in terms of hours, we see that the units here, miles, and the units here, miles per hour, both contain miles. And when we're dividing miles by miles per hour, we're dividing the miles away. They just cancel out. The per hour means like 1 every hour, right? You're doing, it's like the reciprocal of hour. And when you're dividing it by per hour, you're just getting hour, right? This is just a really basic explanation of how the units can work together to get you the right units and stuff like that. But that doesn't matter too much. Just understand that if you're working in miles per hour, you're going to get your time in hours and not in like seconds or something like that. So by working this out, we get 1.75 hours, which is the same as 1 hour and 45 minutes. I just personally do not like working in decimals of hours because the clocks run on 60 minutes per hour. It's weird having decimals which are 100 per one. Um, so now we have a 1 hour 45 minutes as the total journey to travel. However, we need to take into account that it takes 15 minutes to pass through each lock. And we know that there are two locks, which adds 2 times 15 mins, which is adding a half an hour to our journey. So 1 hour 45 mins plus 30 minutes, we get 2 hours and 15 minutes. So, yeah, it says give your answer in hours and minutes, which is why we've done this conversion here from 1.75 hours to hours and minutes. So 2 hours, 15 minutes is the correct answer here. And now we're just going to move on to 4E, which is the last question on this exam. Now, after the holiday, Mikey and his friend Joe each post some photographs onto social media. The table shows how many likes each photograph received. And Mikey, as we can see, has posted one more picture than Joe has. Calculate the mean number of likes for each set of photographs. Use your values to complete the statement below, and you must show all of your working. So, um, so, so, um, here we see that Mikey has 1, 2, 3, 4, 5, 6, 7, 8 posts that he has posted, and Joe has posted 7. This can be useful in just a second. And the way we're going to do this is by taking a mean. Obviously, this question we're asking about finding the mean of number of likes. So we're just going to simply do 10 plus 15 plus 11 plus 12 plus 10 plus 14 plus 20 plus 8. Because as I've said before, to calculate a mean, you just have to add up all of your values and then divide it by the number of values that there are. So really quickly, just going to add it up. Mikey has a total of 100 likes, whereas Joe has a total of only 93 likes. And this is just done by 10 plus 15, blah, 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 to get Mikey's. And for Joe's is 12 plus 13 plus 10 plus 18 plus 25 plus 9 plus 6. You get the idea. So now we need to find the mean for both Mikey and Joe's posts. Mean number of likes. So the number of posts that Mikey has done, as I've said earlier, is 8. He's posted 8 times. That means the mean is 100 divided by 8. And for Joe, he's posted 7 times. So that's 93 divided by 7. And then you type these numbers into your calculator, and you'll see that this is the same as 12.5, and this is the same, this is the same as 13.3. So we see that even though, although Mikey had a larger total number of likes, his mean or his average number of likes is lower than Joe's mean. I should be saying mean instead of average because there are a lot of different types of averaging. Um, so we see that on average, Joe did receive more likes than Mikey. And that should be the answer. So that'll be the end of the test. Obviously, in your actual exam, please make sure to go back on your answers and double check again. If you have any time remaining, which you should, go back and check a few times, and just make sure you've actually got everything correct and done. But yeah, that was the NCFE Level 2 Functional Skills in Maths practice paper. I hope that was helpful, and thank you for, if you've watched this far, thank you for sticking through.